All right, functional groups. There's a lot of them, and you've got to remember all of them. In this video, we're going to go through some of the kind of dumb ways that I remember functional groups, and maybe it'll help you to remember them when you think of the way that I remember them, okay? We're going to start with this one right here. This is an alkane, not necessarily a functional group, but an alkane is just a molecule that only has single bonds or sigma bonds. And we'll see what the difference is when we look at this molecule right here. This functional group, this is called an alkene. And finally we have alkynes right here. Okay, how can we remember the difference? Well, if we think that A comes before E, which comes before Y, we can remember that one bond comes before two bonds, and that comes before three bonds. Easy enough to remember. This would be the functional group right here in the alkyne, and this would be the functional group for the alkane. Okay, this one right here. You might identify this structure as benzene. You might know that already, but when it's considered a functional group, so let's say we had something like this butane molecule, and it had the benzene attached to it, something like that. We would call this group a phenyl. Okay. This one right here, this is a little different. When there's another carbon in between, we would call this a benzyl. You can kind of remember the difference because there's a bend in between the benzene ring and the molecule. Dumb way to remember it, but it might stick. This right here, we call this functional group an amine or an amine. We call this a primary amine. We might designate primary as a first degree, something like that. When we substitute one of those H's with another carbon chain designated as R, we'd call this a secondary amine. And finally, if there's three carbon groups attached to the end, we call this a tertiary amine. Okay, easy enough. Increasing the number of carbon groups, we increase the number that we call it. Let's look at some of the functional groups that are more based off of oxygen. So these functional groups, they all have oxygen in them. We call this portion right here the carbonyl group, but when there's two carbon chains bonded to the carbonyl group, we call this overall structure a ketone, okay? When we add an H instead of one of the R groups, we're going to call this an aldehyde. I remember that because there's an H in aldehyde and an H in the structure. When we add an OH group, we call this a carboxylic acid. Okay? And you'll begin to remember why it's called that, because this hydrogen right here is very acidic. It can pop off the molecule pretty easily because it has resonance stabilization between the oxygens to stabilize the negative charge that's in there. Finally, if we have something that looks kind of like a carboxylic acid, but instead of an H, we have another R group, we're going to call this an ester. And if we're replacing the oxygen with an N, it's kind of like amine, but we're going to call it amide. Continuing on with some of the functional groups with oxygen, we have this one right here, we call these alcohols. I kind of remember it because if you spell alcohol with another H in there, alcohol, like this is the functional group. Makes it an alcohol. This one we call an ether. An ether is an oxygen with R's bonded on ether side. Haha, We call this right here alkyl halides. So our X could mean any halide such as bromine, fluorine, iodine, chlorine, anything like that. We would call it a bromide, fluoride, iodide, chloride, something like that. And finally, we have this guy right here. It's like an alcohol, but because there's an H, or an S, I'm sorry, we call it a thiol. And last but not least, we have two lesser known functional groups. We call this one right here a nitrile. We can remember that there's an N for nitrile. And we call this one right here an epoxide. I remember it because there's an X in epoxide, and this kind of makes an X shape. Okay, epoxides just have a triangle formation between two oxygens, one oxygen and two carbons, with R groups on the side. So let's do